Hi everyone, I hope you're okay. I'll be doing video number 2, guys, which means I'm doing question 2. Please note that there is another video which has been uploaded whereby I tackled question 1. If you are new to the channel, please don't forget to subscribe. Your subscription will help us to grow the channel and maybe we can reach to other learners who might need help as well. Okay, question 2. We are given an arithmetic series, né? And the arithmetic series is 7, 12, and 17. The first thing that you need to know about an arithmetic series is that it has a common difference, and that difference is the first difference, né? So the first difference is common in an arithmetic series. How do I get my first difference? I'll simply say t2 minus t1. This will give me 5. Then t3 minus t2 will also give me 5. So my common difference is 5. Okay, so now they want me to determine the value of the 91st term. I know that tn is equal to a plus n minus 1d. Are we together? They want me to find the 91st term, right? So whenever I see n, I'll just substitute with 91. So I'll simply have 91. And my first term is equal to 7. My difference is equal to 5. So I'll just punch my calculator to find the 91st term. Okay, this will give me, I'll simply say 7 plus 91 minus 1 multiplied by 5. This will give me 457. So the 91st term is equal to 457. This is 457. And then the second question, they want me to calculate the sum of the first 91 terms. Okay, there are only 3 things I need for me to calculate the sum. The first thing I need is the value of a. Secondly, I need d, and then thirdly, I need n. Are you together? There are 2 ways in which I can find the sum in this question, right? Because I do know the last term of my sequence is 457. There are 2 ways. I'll just do both of them. No? I know that Sn is equal to n over 2. Then I'll have 2a plus n minus 1d. Sum of the first 91 terms, right? Which simply means that my n is 91. The value of a is 7. 91 minus 1. The value of d is 5. So whenever I just whenever I'm supposed to find the sum, the only 3 things I need, I will need my first term, my common difference, as well as as well as the number of terms. So this will give me 21,112. Another way I could have done this, since I have the last term, I could have used the formula that says Sn is equal to n over 2. Then I'll have a plus l, where l represents the last term of my sequence, right? So 91 over 2 is equal to 7 plus the last term is 457. Whenever I punch this on my calculator, it should give me the same answer, which is 21,112. So the sum of the first 91 terms is simply 21,112. Okay, and then now they want us to calculate the value of n, in which tn is 517. Okay, I'm supposed to find the position of 517 in my sequence. Basically, I need to find n. Okay, so I'll simply say tn is equal to a plus n minus 1d. Why am I using this formula? Because this formula is the one that generates all the terms of an arithmetic sequence, right? So Right now, I know the term, but I don't know its position. So whenever I find n will give me the position of the term in the sequence. The value of a is 7. I don't know n, and I know that the difference is 5. When I take the 7 to the other side, I'll simply have 510 is equal to 5 n minus 1. When I divide both sides by 5 rather, I'll simply get 102, and then I'll have n minus 1 here, then n will simply 103. So this thing simply means that the 103rd term of the sequence is the one which is equal to 517. Okay. 2.2, we are given a quadratic number pattern, right? And we are not given a number pattern rather, but a quadratic number pattern is being described to us. We are supposed to answer the questions that follow. Okay, let me erase so that I can create space for me to write. Okay, I'm told that the first term is equal to 3. So T1 is 3. And I'm also told that T2 minus T1 is 9. Simply means the first term of the first difference is 9. Another thing that I was told was that T3 minus T2 is 21. Okay. They want me to find they want me to show that the fifth term of the sequence is 111. Okay, remember that, guys, on your quadratic number pattern, your first difference is arithmetic and the second difference is constant. Are you together? So my second difference I'll simply have 12 there. How do I find 12? I'll say 21 minus 9. This will give me 12. And I know that it is constant, so the second difference is always 12, right? So here I'll get 33, and then I'll get 45, right? So for me to show that the fifth term is just 111, all I need to do is to keep on adding these terms. 9 plus 3, this will give me 12. 12 plus 21, this will give me 33. 33 plus 33, this will give me 66. And then 66 plus 45, this will give me 111. So this is how I would have shown that the fifth term of the sequence is 111. Okay, and then now I'm supposed to show that the general formula of the quadratic pattern is given by that. So basically I simply need to find out, remember that the general formula is given by Tn is equal to a n squared plus bn plus c. So basically I just need to find the values of a, b, and c, right? How can I find a? I know that 2a is equal to the second difference. That means a is equal to 6. Are you together? How can I find b? I know that 3a, let me use a different color. I know that 3a plus b is equal to the first term of the first difference, which is equal to 9. So I've already calculated the value of a to be 6. I just need to find b. Are you together? 3 multiplied by 6 is 18. When I take the 18 to the other side, I'll simply have 9 minus 18, and then b will be equal to negative 9. Are you together? And then now I just need to find c. I know that a plus b plus c is equal to the first term of the sequence. The value of a is 6. The value of b is negative 9. I don't know C. All together. So therefore, C is equal to a positive 6. So now I can conclude that Tn is equal to 6n squared minus 9n plus 6. Now I have proven that the general term for my quadratic number pattern is given by that. Okay, and then 2.2.3, I'm supposed to show that the pattern is increasing for all natural numbers. How can I do that? How can I show that something is increasing? A function is increasing if and only if its derivative is greater than 0 for all values of n. So I have Tn, which is equal to 6n squared minus 9n plus 6, right? So the derivative of n is simply 12n minus 9. For something to be increasing, it simply means that its derivative must be greater than 0. So that means 12n minus 9 should be greater than 0. 12n should be greater than 9, and then n should be greater than 9 over 12, because I'll divide both sides by 12, right? And 9 over 12 is simply 3 over 4. Right, together. But remember that, guys, we're dealing with sequences, nah? And n is the number of things. We cannot have a number of you cannot have a number of things or a position of a term as a fraction. So your n has to be a natural number. Indeed it is here, because I know that n can be anything which is greater than 3 over 4, right? So which simply means that n is greater or equal to 1. Are you together? Remember that 1 is the first natural number we have on the number system. So I can therefore conclude that Tn, no, this guy is always increasing for n greater or equal to 1. That's how you're supposed to tackle question 2.2.3, guys. Please, guys, don't forget to subscribe, like the video if you are happy with what you are doing. Share as much as you can so that you can reach to many learners as we can. And yeah, just stay tuned. Video number 3 is coming.